On July the 18th, in the city of Glasgow, police car Alpha 2 was on patrol.
Control to Alpha 2.
Alpha 2 to control.
Would you attend a robbery at licensed grocers, 906 Socky Hall Street? Witness at scene will remain till you arrive. CID have been informed. Over.
Roger, Alpha 2, that's noted. Attending, over.
This robbery.
The witness had been passing the shop when he heard someone shout out. As he went to go in, two masked men pushed their way out through the narrow doorway, knocked him to the ground, and then ran off up a nearby passage. As any Glaswegian will tell you, the passage led to a close, and a close has many exits. Back in the shop, the owner lay seriously injured, and as the call went out for an ambulance, the scene of crime officer arrived. The scene of crime officer will look for and collect any possible clues that might be used as evidence. Policemen are trained to be observant, to notice details, and fleeing criminals often panic and throw things away. This mask, and another found later, matched the description given by the witness.
Alpha 2 to control.
In their rush to get away, the two criminals had got stuck in the narrow doorway, and the door frame was a likely place to look for clues. As well as the red fabric, the officer also found a small bundle of blue fibers and a small bundle of maroon, of dark red fibers. Now, the witness had said that one man was wearing a red shirt and a blue sleeveless jumper, and the other a maroon pullover. That evening, the local paper asked people to come forward if they'd seen anyone who fitted the descriptions. Ian Hamilton is the forensic scientist who was asked to do the all-important analysis of the fibers and fabrics. Now, forensic science, like all science, depends on careful observation and keeping accurate records of what's seen. Ian first checked the police list to make sure he had everything, and then set about examining each item stage by stage. Now, you can't afford to make mistakes in this kind of work. Whatever is on the label goes into Ian's own notes, so that nothing is wrongly identified. Now, what does it look like? After all the items are looked at and recorded, the first one out of its bag is one of the masks. Sticky tape is used to remove anything that might have caught on the knitted fabric. The tape is then stuck onto a piece of acetate to protect any likely evidence and to make it easier to examine. Both masks, inside and out, were examined like this, but Ian found nothing. This, and the fact that both masks seemed to be made from the sleeves of the same knitted jumper, were recorded in his notes. The next stage is to make slides of the various fibers. So first, identify the slide. Next, a drop of liquid paraffin. And now for the fibers. In this case, there were plenty to choose from, but sometimes Ian has to work with just a single fiber. Finally, On with the cover slip. Slides were also made with blue fibers from the door frame and with fibers from both masks. But making a slide from a woven fabric is more difficult. The fibers are twisted into the thread and they have to be teased out. A drop of liquid paraffin and on with the cover slip. Now the question is, are the fibers natural, that is wool or cotton, silk is too rare, or are they man-made? To help you sort out which is which, this is a special scanning electron microscope picture of a wool fiber. Only wool fibers have this scaly surface. And this is a cotton fiber. It's a collapsed tube. Cotton is a hollow fiber. Man-made fibers are made by melting plastics materials and pushing them through tiny holes like this. They come out the other side as solid filaments, many kilometers in length. Under the scanning electron microscope, the filaments are solid, round and smooth. Now you won't see pictures as clear as this again. We show them just to give you a better idea of what to look for. This is a comparison microscope. Usually, Ian would use the same sort of microscope that you use. But to help you further, he's using the comparison microscope because you can look at two slides at the same time and compare them. On the right-hand side, the maroon fibers found at the scene of the crime. On the left-hand side, a slide that Ian has made of wool fibers. Right, let's have a look. First, bring them together. And there really is no doubt about that. The fibers are wool. Now change the maroon fibers for the blue fibers. Line them up again. And again, no doubt. The blue fibers are not wool. So now change the wool fibers on the left side for another slide that Ian has made, this time of cotton fibers. And the blue fibers are not cotton either. They're man-made. But Ian can't tell yet which material they're made of. Now change the blue fibers for the fibers from the red fabric. Not much doubt about that. A twisted cotton fiber tube. But there's something else here. That's not cotton, and it's certainly not wool. It's man-made. So the red woven fabric is a mixture of cotton and an unknown man-made material. Now change the red woven fabric for the blue fibers from the first mask. Like the blue fibers from the door frame, they're man-made too. And so are the fibers from the second mask. So what are the man-made red and the man-made blue fibers made of? To find this out, Ian first used this polarizing microscope. It uses polarized light, and you note the color changes when the fibers are turned through 90 or 180 degrees. You don't see normal colors. A blue fiber from the door frame and fibers from the masks looked like this. Yellow to start with, and then blue, and back to yellow again. This yellow, blue, yellow change meant that the fibers were either acrylic or triacetate. The way to find out which it is to do a chemical test. Triacetate dissolves in a mixture of calcium chloride and formic acid. Acrylic doesn't. Just a drop on the slide is pulled by capillary action under the cover slip. The fibers don't dissolve, so they're not triacetate. If they're acrylic, they'll dissolve in concentrated nitric acid. No doubt about that. So the blue fibers are acrylic. The same tests on fibers from the two blue masks showed them to be acrylic too. Under the polarizing microscope, the man-made red fiber looked like this. It wasn't very clear, and Ian couldn't say for certain what it was made from, but he thought it might be polyester, so he went through the chemical tests. There was no reaction to calcium chloride and formic acid, so the next test was with 75% sulfuric acid. Again, no reaction. So the final test. Concentrated sulfuric acid will dissolve polyester. And there it goes. So everything about the fibers and fabrics was known. But the case was to take a more serious turn. The doctors were getting worried for the life of the injured man. Acting on a tip-off, an officer paid a visit to the home of the brothers McHine. From the evidence of the eyewitness and the forensic evidence, the police now knew that they were looking for one criminal with a maroon woolen pullover and another with a red cotton and polyester shirt and a blue acrylic jumper with the sleeves cut off. When the two men were arrested, a maroon pullover was found, which, together with the two burned fragments, went to Ian for analysis. Again, all the details were recorded in his notes. Then, a small bundle of fibers was mounted on a slide. Similarly, details of the blue burned fragment were noted. But before a slide was made, the color and pattern of knitting were compared with the fabric in the masks. The red burned fabric was part of the cuff of a shirt or blouse, and Ian compared the color and weave pattern with the small fragment found caught on the nail of the shop door frame. Finally, a thread from the cuff and fibers from the thread to mount on the slide. It didn't take Ian long to find out that the maroon pullover was wool, the blue burned fragment acrylic, and the red burned cuff a mixture of cotton and polyester. But were they from the same fabric as the fibers found at the scene of the crime? It was back to the comparison microscope, this time to compare the color of the fibers. To Ian's trained eye, the maroon color looked the same in both samples. The color of the blue fibers in both samples also looked the same. And so did the red. But this was not enough. The charge was now murder. Ian had to be sure beyond any reasonable doubt. This microscope is made to help analyze the dyes that have been used to color the fibers. When the fiber is in position, The color that is marked out by the black rectangle is analyzed. The result is in the form of a graph. On the left, the graph produced for the dye in the maroon fibers from the pullover. On the right, the graph for the dye in the maroon fibers found on the door frame. These are the graphs for the dye in the blue fibers. And these, the graphs for the dye in the red fibers. It looked very much as though the dyes were the same. But before he could be sure, Ian had to do one more test. In this test, a small amount of fiber is pushed to the bottom of a very thin tube. These are the maroon fibers found on the door frame. Then, a drop of solvent is added. The tube is then sealed and heated in an oven for 20 minutes. Here's one that's been in the oven, and you can see that the dye has dissolved in the solvent. The dye is extracted from the pullover fibers in the same way. Now they're in solution, the dyes can be compared by a process known as thin layer chromatography. A drop of dye from each sample is placed on a specially coated card. These are the maroon dyes. The plastic card is then put into a jar of liquid which can separate the different colors in the dye. As it rises up, the liquid takes whatever is in the dye with it. After about 20 minutes, you can see the pattern. The dyes were identical. And the same test with the dyes from the blue fibers and the dyes from the red fibers gave the same positive results. As Ian's records show, beyond any reasonable doubt, the fibers at the scene of the crime were from the clothes found at the McHines' home. The work of a forensic scientist depends upon careful observation, comparison, careful testing and checking of results, and keeping accurate records.